Well, hello there folks. So we've got a bit of jazz going on, we've got the Norwich tie, we've got the cufflinks, which must mean that once again we've made it to Friday. So that's good news, isn't it? We're on the sunny side of the street now. Okay, so what are we going to do? Well, we're going to finish off functions, but before we do, I've got a little bit of a puzzle treat for you. So anyone who likes chess may well enjoy this. Take a look at it. If you don't fancy doing it, it doesn't matter. But if you do fancy a go at it, it's a really good kind of, having a go at puzzles is a really good way of training your brain to try to make out what you're going to do whenever you get one of those questions in the exam, which happens a lot on the higher paper particularly, where you think, what the flip's going on here? I don't know what to do. And you just have to try doing something. So we're going to have a little look at a little Knight's Tour puzzle. Right, there's two puzzles here. I'm gonna cover up the rectangles one. You might want to have a go at that if you want. We might go through that another time. So cover that up so that we can focus on here. Now, a Knight's Tour is what happens if you move a knight around a chessboard so that he visits every single square exactly once, with no repeats. So it says 1, so it's starting at 1, it's going to finish at 100. And what we've got to do is we've got to make sure we get fill in all the numbers that aren't there. So I know that it's 3. So a knight, just in case you didn't know, can move either 1 square and then 2, so it's a jump to that square, or 2 squares and then 1. You can do that in any direction. So from here, the knight could go to 2 and 1 to there, could go 1 and 2 to there, could go 1 and 2 to there, or 2 and 1 to there. Now, if he does those 4 moves, any of those 4 moves, if he does this move, he can't reach the 3. If he does this move, he can't reach the 3. But from here, he can go 2, 1. And from here can go 2, 1. So I know, I'm just going to do this lightly with pencil, that the second move must be either there or there. Now, do I know which one? No, I don't at the moment. So I'm just going to use pencil for now, because later on, one of those is going to be needed for the other one. So I think this is going to have to be the way to do this for myself. Now I've got to get from there to here. Now, I could go, it's quite a long stretch, so I'm going to have to do long ones. So it's 2 and 1, so 4 could be there and 4 could be there, but 5 is going to have to be there. So I know, I'm convinced that 5 must be there. So I'm going to ink in 5. That's confident of me. And I'm going to put a little pencil 4 there and a pencil 4 there, and that's the way I'm going to do it. Carry on if you've got time. Don't necessarily do this now. This could be something later on in the day. If someone else is watching something on TV that you don't like or something like that, a little thing to keep you going. So copy down the thing or print it off or whatever, and see if you can do it. The first person to get me a correct solution sent in will get a shout out. Okay. Ooh, I hear you say, and ooh indeed. But anyway, we will move on now to functions, because I know you're desperate to get to it. Right, now we're going to launch straight in with your first composite function. So get ready for this. Now this is what's strange is you do the function. I want you to write this down so that you always do this right. Do the function closest to the bracket first. So you look at this, you might think this is function g followed by function f, but it's not. It's function f, and then you work to the left and go function g. Now what it means is that you put the value 3 into function f, and then whatever you get out of that you put into function g. So if I do f of 3, that's going to be 2 times 3 take 4, which is 6 take 4, which is 2. And now I'm going to do g of 2, because that's what I've got out of f. So it's a composite function, so you're timesing it by 2 and taking 4, then whatever you've got, you're timesing that by 3 and adding 5. So I've got my 3 times the 2 that we've got there, plus 5. 3 2s are 6, add 5 gets us 11. So there you go, there's your first composite function. And now we're going to have another little go at an inverse function. So the function itself is 2x take 4. Pause the video and see if you can have a go before I remind you at all. Right, so this is about reversing the procedure to find out what x must have been in order to get 2x minus 4. So what we do is we say let y equal the f of x, and we rearrange y equals 2x take 4 to make x the subject. So that would be reverse BIDMAS, add 4, gives us y add 4 on this side and 2x. And then that means times 2, so we divide by 2. And we get y plus 4 over 2 equals x. And then at the end, finally, replace the y with x. And what I mean by that is I want the expression for it, so I just want this bit. So I can say that the inverse function is x add 4 over 2. And because they just asked for an expression, you don't have to put that bit in there, but you won't lose any marks for doing it. And I think it makes more sense of it. Okay, next one, solve function f and function g. So just to remind you, function f was 2x take 4, function g is 3x plus 5. So pause the video, make an equation and see if you can solve it. Pause the video now. So you should have 2x take 4 equals 3x plus 5. If you didn't, now pause the video and have a go at solving it. And we want our x's to one side. I've got more x's over here, so I'm going to take 2x from this side to give me negative 4 equals x. 3 take 2 is 1, isn't it? And then I'm going to take 5. When I take 5 from negative 4, I get more negative, so I've got negative 9 is my final answer. Okay, that's the first page. Moving on. Right, so question 6, composite function, but this time we haven't got a value in here. It wants to know what one function would look like, which if you put a number into, remember you do the one close to the bracket first, into g and square it, and then take that and stick that in there instead of the x and do 3 times that and add 1, what would it be? And these are not as tricky as you might think, because function g is that. So it's saying we're going to put function g into f. So all we have to do is say, instead of x, I'm going to have this function here. So it's going to give me 3x squared add 1. And that is it. 3x squared plus 1. Don't know why I've written that all out again. Well, you should always put it on the dotted line. That's it. That's why I did that. Right, now we've got to go the other way. So pause the video and see if you can do that for me. So you start off with, you've got your f of x being 3x plus 1. And then we're going to put that in instead of the x. So this goes in instead of x. So instead of writing x, I'm going to write that. So I'm going to write Woo, wrong way around. I'm going to write 3x plus 1, and I need to square that, so I'm going to put that in a bracket and square it. Maybe a bracket instead of a loop would be better there. And finally, they want us to solve the first one that we made equals the other one. So all you've got to do, you get 1 mark just for setting up the equation. So pause the video and see if you can do that for me. So fg of x is this, 3x squared plus 1. gf of x is this, so equals 3x plus 1 squared. And now you've got to attempt to solve that equation. So pause the video and have a go. If you're not sure what to do to begin, start by expanding this bracket. So expanding that bracket gives us 3x add 1, 3x add 1. 3x times 3x is 9x squared. 1 times 3x is 3x. 1 times 3x is 3x, and 1 times 1 is 1. We peanut our 3x's together, add them, and that's going to give us 6x. So we're going to have 3x squared plus 1 is equal to 9x squared plus 6x plus 1. What you now have, folks, is a quadratic equation. So how do you solve a quadratic equation? That's right, you've got to make it equal to 0. So as we've got more on this side, let's get rid of those. So take 3x squared and take 1 from both sides. 9 take 3 is 6, so we've got 6x squared. The 6x stays the same, and we take the 1 away, so there's no normal numbers. Now that we've got that, we need to factorize this. Now, because there's no normal numbers and we've got x in both, that means we can use a single bracket to factorize this. So it's going to be 6x goes into both, doesn't it? So 6x times x is 6x squared. 6 times x times 1 is 6x. And the reason that happens, folks, is because to get nothing on the end, you could, if you wanted to, write it as 6x plus 0, x plus 1. So there is a second bracket, but it's kind of pointless, so we only need the one factor outside it. Right, so now we still solve this in the same way, because this 6x is a number, x plus 1 is a number. One of them must be 0 when they're multiplied together, because we get an answer of 0. So either 6x equals 0 or x plus 1 equals 0. If 6x is equal to 0, you divide by 6. 0 divided by 6 is still 0. So x equals 0. And the other solution of x will be, take 1 from both sides to make that equal to 0, make that bracket equal to 0, is -1. Great. Now, I thought, being such a lovely person as I am, I wouldn't give you the nastiest problem, the last problem on these worksheets to send in to me. I thought I'd ask for this one. So question 7, here's part A, here's part B. If you can't print it off, then just copy it down from there. And then part C is that, solving the inverse functions being equal to each other. So it's all about the inverse functions for what I'd like you to send in to me. We are going to carry on now with question 8. So pause the video and have a little go at this. Right, now it's not asking for a number because we're not putting a number in, and what we're doing is we're putting x negative x take 2 in, and that's what goes in. So that's going in instead of our x. So all you've got to do to get the marks for this is say that our function of x is going to be x take 2, and that's what we're going to square instead of x take 1. And it doesn't say simplify it, So you could just leave it like that, but that's not the nicest way to do that. So we're going to expand. In fact, I could use a grid, but I think x squared, when we x minus 2 times x minus 2, that's what we're talking about, isn't it? So you're going to have 2 add 2 is 4, so you're going to have negative 4x. Negative 2 times negative 2 is plus 4, and then take 1. So it is going to be better, and I would have thought for 2 marks you should do it, but they should have said leaving your answer in its simplest form. So we get x squared take 4x plus 3. Hence solve f of x minus 2 equals 0. Sorry about that outrageous dropping of the pen lid. So all you have to do is chuck that in there. X squared take 4x plus 3 is equal to 0. And now solve that equation for me. Pause the video, give it a go. So we are looking for two numbers that multiply together to give you plus 3, but add to give you negative 4. Well, there's only two numbers that multiply together to give you 3, 3 and 1. Well, as well as the negatives, and it's the negatives we want, because when you add two negatives together, you get more negative. So x take 1, x take 3 is going to equal 0. If you don't like factorising and you like using the quadratic formula, by all means knock yourself out, use that. So now we need to make the bracket equal to 0, don't we? So plus 1 would make that one equal to 0, plus 3 would make that equal to 0. So x equals 1, x equals 3 are our final solutions, and you need both of them to get both marks. Right, last up we've got question 9. Pause the video, see what you think. So we need to find the inverse function. So we let y equal that. Y equals 4x take 1, and we're going to rearrange it to make x the subject. So I add 1 to both sides, and then I divide by 4, and I get that. Now I substitute, I replace y with x at the end. You don't have to write that down if you're doing it in the exam. And we get the inverse function of x being x plus 1 over 4. So you're just reversing the process. Reversing the process of multiplying by 4 and then taking 1 is adding 1 and then dividing by 4. That's all we're saying. Function g is defined such as g, which is something times x squared, where k is a constant. So we want to find out what that something is. Given that fg2 equals 12, find the value of k. So the first thing that would happen is we would have kx squared, and then kx squared is going to be put into function f. We know that function f is 4x take 1. So fg for x is going to be kx squared times by 4 and then take 1, because that kx squared is going to be put in instead of x. So let's make of that what we can. 4 and we, so 4 kx squared take 1. Now we know that the x value is 2. So we can put 2 in instead of x. And we know it's all going to be worth 12. So let's put that 12 in there. So 12 is equal to 4k times 2 squared. And take 1. So 2 squared is 4, isn't it? 4 times 4 is 16. So I'm going to have 16k take 1. So then I'm going to add 1 to both sides to give me 13 equals 16k. And it might not be a very nice answer, but that does not mean it's wrong. They're just looking to test your confidence at this point in your algebra. Sometimes it's a nice answer, sometimes it isn't. So then we've just got to divide by 16. Now don't worry about doing your division by 16, just write it as a fraction. K equals 13 over 16 is your correct final answer. Right, that's all we've got time for today, folks. I'm looking forward to seeing what you send me for question 7, and then we'll carry on next time. Cheerio, have a lovely weekend.